All right, well, thank you all for being here, both everybody in the room and also on Zoom. So you're at the Building Digital Infrastructure for Interdisciplinary Collaboration and Data-Driven Solutions. My name is John Dawes. I'm the Executive Director and the co-founder of the Commons. I come from a background of GIS. I have my master's in GIS, and then through GIS, I've kind of found software development. And I'll let my colleague, Brendan McIntyre, introduce himself. So,
yeah, my name is Brendan McIntyre. I'm a software developer.
Cool. So just to dive in just quickly about the Commons, and then we'll go through the agenda and kind of materials for today's session. So our organization, we're a 501c3 based out of Washington, D.C., founded in 2016. Our work, we're primarily focused in supporting local government, state and federal government and foundations, as well as environmental groups with being able to access more robust software development capacity and resources. So we're a team consisting of environmental policy folks, as well as software developers that really work to kind of build solutions and capacity for groups that are working to improve the natural world. Most of our application development that we tackle is spatial, and then we're really focused on being able to measure environmental outcomes. So we do a lot of work supporting restoration practitioners with being able to measure environmental outcomes, and this is predominantly using in situ data that they're producing in the field. And we do this through our digital services program and also through our Field Doc system. And we'll talk a little bit more about that here on the agenda. So just quickly, just so that we can kind of get a sense for the audience, I'd love to kind of learn more about the audience in the room here. So I've got our Slido up, and it would be awesome if you guys could participate. So just in terms of getting to know each other, it would be really helpful to feel free to share your area of expertise. I think most importantly, like, what is a hobby or something that you're really excited about? What gets you out of bed in the morning? And while you guys pull that up and fill it out, I can kind of go and share mine. And it's hard for me to like fit on one, but I'm really passionate about bikes. I love riding bikes, and also building systems where the solution works really well with an environmental organization's workflow, where they don't have access to resources, and you can kind of go from planning out a project and kind of seeing that into fruition. Oh, and awesome, we've got a biking person. Nice, business intelligence, chemistry, yeah, really, really awesome. Brendan, do you wanna share just quickly?
Yeah, I'm a hiker.
So.
Mountain climbing. More peaks to go in New Hampshire, 44,000 group, so
sweet.
Time to get those done soon.
Nice. Oil painting from New Orleans. I think I know who that is, so that's awesome. Cool. So wonderful. So let's go through, and then we will dive fully into it, but I want to go through just kind of agenda and logistics so that we can kind of make the best use of our time. So with our discussion today, and this will be a really, a fairly interactive one, we're going to go through kind of some of the core challenges and benefits for documenting restoration at scale. So again, a lot of our work is focused on helping organizations quantify restoration activities. And what do I mean by that? So there are a number of groups out there that go out, receive funding and support to implement things like forest buffers or introduce agricultural cover crops. So we're going to talk and dive pretty deep into some of those challenges and benefits of getting those data collected and some of those respective solutions. And we're gonna do this, and let me get rid of this bar. Sorry, this one keeps popping up. In order to do this, we're gonna go through a fun case study activity. So if you guys could actually scan that QR code. Oh, sorry, go ahead. Yep, yes, no problem. So if you could scan that QR code, that will give you all of the materials for sort of the quick breakout session that we'll do to talk about sort of data standardization in the context of restoration. We have some case studies queued up that kind of show how we're addressing some of these challenges with collaboration and building interoperable systems with respect to restoration. And then Brendan's going to dive in and talk a lot about some of the future incentives for data contribution and modeling. And then we'll have ample time for Q&A. I will plan on, breaking out parts of this, session so that if you guys have questions that come up, I can definitely prompt you and we can kind of address them as we go. So does that sound like a plan? Awesome. All right, so let's go to the next slide. So to really set context here, I want to first talk about kind of the grounding of this, because this is, at ESIP, we're very focused on technology and data, and our organization, especially on the software development side, do focus a lot on product development, product design, but we do all this in the context of really trying to understand the contextual problem that we're trying to solve. And so, because at the Commons we focus a lot on the restoration life cycle, I want to kind of ground everybody and kind of share, respectively, how all of this work fits together. And so, groups that are kind of going out and working to improve water quality and conduct restoration or land protection activities, we've worked to kind of unpack sort of the core work that they do on the day-to-day. And this is kind of defined by, my daughter called this the Mickey Mouse chart, but essentially it's sort of grouped in these respective bins. So a lot of the folks that do this work on the ground go through a planning process where they're effectively trying to identify where best management practices, or BMPs, can be implemented to improve water quality. And these BMPs could be things like forest buffers, grass buffers, cover cropping. If you're in an agricultural setting, it could be a heavy use area, really trying to identify where that should happen. And at each of these steps, there is a place where technology can fit in, right? So for those of you that are doing things like remote sensing, planning and identifying where to site the best practice with, the largest bang for its buck to improve water quality or protect land, those are specific areas where technology can come in. The next step that practitioners tend to go through is this resourcing piece, right? Where whether it's a small watershed organization, maybe a county conservation district office, they have a set of places that they want to work, or relationships with the landowners, and from there, they need to go out and acquire the resources or the funding through programs to essentially get the resources they need to put those practices on the ground. This could look like federal funding opportunities, private grants. There are foundations such as National Fish and Wildlife Foundation, right, that are funding this conservation and land protection work at scale. And so that resourcing step is a very important piece. And as a result of that, we'll talk about report and verify in a second. But once those resources are obtained, then there's this process of implementation, where again, if you guys can be thinking about where technology can fit into this and data, a lot of this comes down to pre-implementation modeling and monitoring, right? So if I'm on a farm, I want to know, what are the current conditions of water quality or the resource that I'm trying to protect, and then after implementation, I can look back and see how those changes have functioned on the landscape. And then obviously this is a very easy one, but on the implementation stage, core BMPs are deployed on the landscape. And that leads us to the last step, which is report and verify, where basically those practitioners are saying, okay, we've implemented this practice on the landscape, and we need to report that out to the folks that have invested in the practice in the first place. The other piece with verification that is really exciting, and I think is kind of a new step, is different monitoring and verification efforts, or MRV, where there are technologies such as coolant that are effectively using drones to scan and create 3D models of practices to inform things like carbon stock. So a lot of different areas where technology can kind of get into the picture there. The other key element too is that we have all these solutions and can go very deep. I mean, you could establish presentations and overviews for each of these, but for the sake of today, I just want to illustrate that each of these areas are very ripe for technical intervention, and they do sort of function in a siloed manner. And so we're looking to figure out a way to be able to break down those silos and put together technology to be supportive in one respective approach. So any questions there about the restoration life cycle? I'm just going to pause and take a breath for a minute. Does that make sense to everyone? Just want to make sure we're all on the same page. Anything, questions, comments? Going once? All right, cool. We will keep moving. So really quickly, on the technical side, I love kind of like looking at kind of quotes and historic folks that kind of resonate and align with this. And this is just kind of another fun Slido breakout opportunity. I want you guys to look at this quote. So art is the flower, life is the green leaf, nature doesn't draw in straight lines. And I want you guys to think about kind of how this relates to our problem statement. And here's the next Slido. So let me pull up this poll really fast, bear with me. All right, so I'd like you to share thoughts on this quote. So how does it relate to producing structured data for restoration efforts? And then this is the bonus point. If you can share a fun fact about Charles McIntosh for anybody who's kind of a history buff in the room. So anybody? All right, I see people typing. That's cool. So we'll give it a couple more minutes, and then we can run through it. Let's see here. All right, yep, nuance is important. That's really good. Yep, good. This is great. All right. Does anybody have any, while we're waiting on a few more responses just for fun, yep, adaptive and flexible, huge, yep. Does anybody, you can even call it out, any like fun facts that you guys know about McIntosh? All right, so he is sort of the father of the Glasgow Four, which is like a huge architectural renaissance in Glasgow, Scotland. It's definitely amazing to kind of look at his work, but he also sort of pioneered some of this biophilia design where he drew from a lot of inspiration from nature. And as we sort of unpack this quote and kind of how it relates to what we're talking about today, we really believe that our data structures and approaches to technology really kind of need to follow this flexible approach that we see in systems like nature, and that we're obviously through these restoration efforts trying to improve and protect nature, so our data system should follow that. Cool. So thank you for your participation on that one. So let's talk quickly about core challenges as it relates to documenting restoration at scale. And let me, add this guy. Cool. So this is like a really staggering statistic. So in 2022, $200 billion were invested in restoration and land protection activities alone. And this is nationwide, right? And despite all this, these efforts are happening in very siloed areas. And the big challenge that we continue to see on and on again are a lot of siloed data structures where we don't effectively have a standard nomenclature for BMP implementation with really necessary metadata to describe what is happening on the ground. Explicit geospatial data is also very problematic to produce because a lot of the organizations that are conducting the restoration may not have geospatial capabilities. And then, I'm sure some of you are kind of thinking about ideating on problem solving, saying like, well, John, we could use things like remote sensing, right, to figure out where these practices exist on the landscape. And that is like very true and valid. However, attribution, such as funding sources and partnerships, these are things where we do need very robust sets of in situ data to get a clear understanding and build that chain of custody of work that's happening on the ground. So that is, one significant set of challenges. More on the programmatic side, aligning metrics and data reusability for people that are investing in these projects has also served as a big challenge. So conservation foundations, such as National Fish and Wildlife Foundation, have a set of metrics or KPIs that they want to track related to their investment. And it's very often the case that these groups, what they would like to measure with their data are typically different from these foundation partners that are investing in this work. And so it becomes this sort of game of having to collect data really just for the means of reporting. And so that reduces data reusability. And that kind of gets into this current restoration reporting tools and approaches are really siloed on that front. And that also leads to a disproportionate focus on mandated reporting versus what an organization's end user priorities are with the respective data. So these are some big challenges. And just to illustrate, this is another one too that I did kind of breeze over. Unlike remotely sensed data with like satellite imagery or even water quality monitoring data, restoration tracking and BMP sort of lacks a standard nomenclature for what we're calling these restoration practices on the ground. There are some really fantastic resources through USDA and NRCS that provide a standardized list, even through the Chesapeake Bay program, through their urban BMPs and some agricultural practices. But amongst different stakeholders, that standard is really kind of all over the map. And just to illustrate that, again, another slide coming up here, I want to kind of move to just kind of a fun, quick activity on classifying some practices here. And if you guys are not, and let me actually pull this up here. Can you guys see this? Here, let me pull up the image too, just so we have it. And for those of you that are in the drive, definitely feel free to either go through Slido or this respective Jamboard. But I want to illustrate and share with you all just some examples of kind of how difficult it can be to kind of classify practices. And we're going to do this together. And again, if you don't have sort of a restoration or land protection background, that's okay. Do your best. And we can kind of go through this together. But what I'd like you to do, so using either the Jamboard or Slido or both, I'd like you to look at the image on the screen and do two things. So the first is to identify a restoration practice from the image, provide the name, and then describe the environmental benefit that could happen from that respective practice. And so just as a quick example here, let me jump to the Jamboard. I've gotten you all started with one. So right here in this little inlet, right in this section, we have a grass buffer, and a grass buffer filters runoff, fixes carbon, and limits nutrients. So if you guys could try and do that, let's get a few of those in here. And again, we can put those in Slido or up on the Jamboard, and then we'll run through those together. It's a little tricky. Let's see. Let me see some that are coming in. Yep, riparian buffer zones, good. And just full disclosure, this is actually my family's grass-fed Angus beef farm in Pennsylvania, so I'm also kind of like a weird data farmer guy. My dad thinks that I went into this so I could avoid doing farm work. That is not true. Yeah, crop rotation, we do have that. There's some trickier ones too, and I'll give you some hints. If you take a look at sort of this this barnyard area, those are some really big practices as well. Yep, habitat conservation, ponds and trees, yep. So I'll just kind of, just because we want to keep moving on time, but with the barnyard area, so we've got barnyard runoff control. So when you have cattle, you can actually loaf them in a concentrated area so that you can gather up their refuse, spread it effectively based on your nutrient management plan through these concrete pads. That's one. The other big one that a lot of folks miss, just because we're a grass-fed operation, is grazing land. So prescribed grazing is a big one. So in order to make sure that cattle aren't wearing down the land and putting too much nutrients and oversaturating the soils. We move them from paddock to paddock to ensure that they've got a lot of room and that those nutrients can kind of get fixed in the soil there. Cool. So this is awesome. So as you guys can see, we're starting to get, a pretty good list of these different practices. And again, I'm sure that if I really pulled up that standardized USDA list with definitions, you guys could very easily group those practices, to what that conservation standard is. But again, what is really challenging is the way that we sort of talk and structure data around these different practices. It can be very challenging from a modeling perspective too, because as we work to build models for things like nutrient sediment load reduction or carbon, there are some very specific assumptions that have to be in place for when we're trying to compute what those environmental outcomes would be. So this just kind of illustrates some of the challenges with standardization. I think it's also important to note too, depending on where you are in this work, if you're a government agency or a foundation that's farther away from the actual work that's being done, you may not know about these standards, right? So you could call something a forest buffer, but the folks that are working on the ground also call that practice something significantly different. So that alignment challenge is one that really has to be thought through and developed when you're doing restoration at scale. So any questions about that? And again, we're talking through this standard nomenclature challenge. So any questions? Cool. Awesome. Great work classifying VMPs. That's awesome. So let's talk quickly about sort of how we've worked to kind of unpack some of these challenges and address them. I'm going to start actually just quickly with this case study of documenting restoration in the Delaware River Basin. And I think this is a really good example of, let me see if this doesn't seem to be hiding. I think this is a really good example of how conservation and land protection kind of does get deployed, at a scale that is regionally across multiple states, but can kind of serve as a model for working in larger watersheds. So just some background on Delaware River Watershed Initiative. This was a privately funded effort initiated by the William Penn Foundation. It was multi-state and covered the whole DRB. There was significant work involved with Stroud as well as Academy of Natural Sciences to effectively look at and quantify what all of the loads in each HUC 12 watershed were throughout the Delaware River Basin. And this was to really establish like a clear baseline of nutrient and sediment loading rates that need to be addressed throughout the Delaware, and also yielded specific hotspots or focus areas and clusters of where work had to occur on the landscape. And with this work, mechanically from sort of the policy side of this, is William Penn Foundation granted funds to National Fish and Wildlife Foundation's Delaware River program to handle restoration practice implementation. And then Open Space Institute was the recipient of funds for land protection efforts, so conservation easements, fees, et cetera. And what ended up happening is that those funds were then mobilized through a massive network of local conservation professionals, so county conservation district offices, again, small watershed organizations, state government. And what's really unique about this process is this was not a federally or state mandated effort, right? It was one private effort that did not correspond to regulatory requirements of the TMDL, which is pretty exciting. And so what ended up happening is that we ended up working to really start to quantify this work. And that was a key area that our organization was brought in to effectively establish a means for tracking these respective practices. This is a progress snapshot of the Delaware River Watershed Initiative in terms of acres implemented. And what's so exciting about this work is that we've effectively been able to document every single practice that was implemented as a result of that funding. And so this was sort of an iterative approach in developing our field doc system to kind of support this effort. We kind of evolved this platform really through understanding those core user needs, right? And so in that restoration lifecycle chart that I had shared, before sort of like proposing a solution, we kind of backed into the solution by really understanding what those tracking requirements were. And so what has been coming out of this is establishing effectively a shared data model. So most of these practitioners in the Delaware, had some idea and some means for documenting work, whether they were putting that into a spreadsheet or a specific data set, but there was sort of no shared understanding of that implementation, let alone a chain of custody. And so what we effectively did is establish a data model where we can document very finely at the practice scale, the location, practice type, practice footprint, and any required metrics to effectively support documentation of that effort. And so I think what we got right with this that is really exciting is that we were able to move beyond just project centroids. Most of these agencies and organizations working to implement this can tell you where they mailed the check, but the composition of the practices and the work that's happening on the ground was not there. And so, like I had said earlier, we've documented essentially every practice that's associated with it. And this is actually informing a number of nutrient sediment load reduction models that can actually determine what is left to improve in terms of lowering nutrient sediment load reductions, because we have that highly accurate spatial data of practice type and practice composition. And because we also have the investment criteria for those practices, we can even get at cost, cost differential on that front. So this is kind of a really exciting step forward. And again, I think it's really important to note that this is only covering off on the data management side. There's so much room for all of these technologies to connect in and support different steps of that restoration life cycle. So, again, core challenges that we work to address there is, breaking down silos on restoration reporting tools. Brendan will talk about this right next here in terms of being able to build incentives for users to contribute data and contribute information, and then also getting those funding sources attributed. So so let me pause quickly for questions. I know that was a lot of ground to cover, and we do have a couple other interactive components, but I just want to pause and address any questions or comments or concerns that anyone has in the room before I turn it to Brendan. So any questions? All right, sounds good. Brendan?
Can you all hear me? Is that the right volume? Okay. Yeah, so as John was just mentioning, we are working with a lot of stakeholders at the ground level, but we're also responding to the needs of folks who are funding restoration efforts and ultimately building pathways for this ground truth local data to flow to interested parties like federal agencies or, in some cases, business interests that are trying to build crediting markets and that sort of thing. It's tough to persuade people to participate in a process that they feel is mandated from the top down and where they ultimately lose ownership of their data. So if it's a box checking exercise, then you get one-off compliance and then people disappear and you've got to coax them back in later when it becomes apparent that you need follow-up. You need to know that the trees that you paid for 10 years ago are either dead or thriving or somewhere in between. And the funding mechanisms for that sort of work are a lot thinner on the ground than the upfront stuff. So planning, design, and then ultimately implementation. So what our team tries to do is, rather than lead with technology first, we try to step all the way back and say, what's the ultimate end goal? And what are the objectives of all the various stakeholders and how can they be, served in ways that don't simply duplicate the same kinds of efforts every 5 to 10 years, which, John and I came up through the Chesapeake region in the mid-Atlantic of the United States, and that's, you've got to corral a bunch of state agencies, local governments, NGOs, and they all have competing interests most of the time. If you've got someone who's running a farm out in West Virginia, they probably, the state of the Bay isn't top of mind for them. They have other concerns, and those are probably, what sort of cost share programs can I take advantage of to keep my farm going while being a good environmental steward. So there's a lot of people work up front, and then ultimately we need to get down to brass tacks and implement technical solutions. So the way we try to do that is by bringing what we try to think of as a bit of a fresh approach that probably doesn't seem very fresh to the folks in this room because you're close to these issues, but a lot of NGOs, a lot of small to medium-sized businesses on up to very large, multi-million-dollar funders and state agencies, they're way behind the curve. So industry, private sector sets the trends and technology, and then decades later, everyone else catches up. And this is usually to do with budgetary constraints, but then also just a lack of time spent and resourcing for building skill sets and making this whole, like building data pipelines and getting the raw materials out of the ground, so to speak, isn't something that you can just snap your fingers and do overnight. People need to be convinced that it's worth their while, and that the old way of just emailing Alice a spreadsheet every 6 months needs to be transformed into something more useful, more 2020s. We are in meetings all the time with people who are, through no fault of their own, they're just sort of stuck in sometimes, entrenched or outmoded ways of data management, and they actually have sort of an adversarial relationship with people who are asking for data because they think of it as a huge multi-year initiative that they need to undertake to satisfy some bureaucrat in an office somewhere who's ultimately might come back and say, well, this wasn't enough, we asked for 10 million acres of buffers and we only got 8.7, so what's the deal? That doesn't inspire confidence in taxpayers either, who are largely responsible for footing the bill for these sorts of initiatives. I mean, we've got great private sector collaborations like we saw with the Delaware, but there needs to be, we need to recognize that technology can serve the stewardship ethic of a lot of ground level organizations as well. And if you appeal to that aspect of their missions and take the time to build confidence and educate folks, that you actually get better outcomes. So what we usually do is we lead with, an explanation of the contemporary technologies that we're seeing to be successful and that break people out of the days where things were in filing cabinets or 6 different versions of the same spreadsheet. And that, again, is probably de rigueur for most of y'all, but bringing people to water is sometimes a very long process. They want the oil flowing through the pipe already when they don't, they need to be convinced that there isn't any oil yet. You need to, again, acquire the raw materials. And this is not only a technology issue, but it's also a priorities thing. So if you're really into paying for on-the-ground implementation, because that's what satisfies your partners and your board and the folks who are backing you, then that's where you focus effort. You're not really concerned about pre and post monitoring. You're not doing landscape surveys ahead of time. And when you are, it's a short-lived initiative that someone thought was a good idea, and then it gets parked in the back for more important issues. So there's a lot of capacity building that needs to occur to convince folks that spending money on technology is actually a really good idea, and the upfront costs get paid off many times over in the long term. But if you're just sort of not rocking the boat, doing things the same way as we've been for the last several decades, then you don't end up with different outcomes. It's just, the people feel stuck, and then they slow down because their mission isn't to wrangle data, it's to plant trees or to convene landowners, talk about land protection and that sort of thing. So they don't think of technology as a benefit, it's more of a hindrance. So we try to break down these barriers a bit by saying, okay, fine. If spreadsheets are what's working for your organization, let's keep doing that. But let's update our practices a bit so that we can get data flowing to the places it needs to be without adding additional organization burden in terms of management time and skill acquisition that a lot of people don't really have the resources to undertake. So I'll preface this next section by saying we're not affiliated with any of these companies. They're just they're in the ecosystem of systems and tools that we're excited to see our stakeholders enjoying a lot of success by using. A lot of the work that we do these days is basically plumbing. We are building pipelines between different services that either support that sort of thing natively, or that we can work collaboratively with to let them know what our folks need and just offer ourselves up to be useful in that effort, because a lot of, in the environmental sector, at least in our little world, the ultimate repositories for data are usually fairly black box that no one understands how they work. They know that the data ends up at the EPA somewhere, and they heard it's on a website that you might be able to find, but once you get there, there's no documentation, there's no understanding for how the government is using that data to inform decision making. So I'll just run through a few of these examples quickly. PipeDream is an example of its connective tissue, so you can connect APIs together without having to manage your own infrastructure. That's really attractive to organizations that don't have tens of thousands of dollars to spend per month on managing infrastructure and hiring the staff that's required for that. This kind of thing is accessible to folks that don't write code, but that do work with data. So what we often see is people who've heard for a long time that they're non-technical. So, there'll be a software project or something at their organization, but it's not for the non-technical people. But we kind of try to flip it around and say there aren't really non-technical staff anywhere. There are people who can acquire technical skills if you spend the time to educate them and show them how it's useful and helpful. Giving them superpowers that they didn't realize they had access to. There's another element to this too, where companies who, and PipeDream is one, they do all their work out in the open. So we aren't trying to connect restoration practitioners to companies who are ultimately going to disappear or aren't transparent about their development process, and you end up with vendor lock-in, that dreaded term. Pipedream and these others that I'll mention shortly, they're good citizens. They're good stewards because they offer discounts to nonprofit organizations and under-resourced organizations who need to take advantage of their software solutions. So that's another thing we look for when we're trying to build out our arsenal of tools. If you're being a good citizen and you're actually trying to raise all boats, then you're probably a good fit for the kind of organizations that we serve. Felt is another one. Definitely check it out. It's a collaborative mapping platform. If you're familiar with Esri tools like ArcGIS Online or Mapbox and that sort of thing, you'll understand Felt. They really try to put the user first and put an emphasis on not closing out people who don't have GIS skills, which is something we see a lot. People feel like GIS is a closed off community that's a bit opaque. They don't realize that they actually can get a lot of work done with some of these newer iterations on old tool sets that were great for people who were programmers and understood the internals, but that don't really translate well to people whose primary day job is installing bioretention facilities or something like that. But we're excited about Felt because it has a lot of potential as a verification utility as well. So people who need to do site visits and track progress over time, track implementation status over time, that's a huge weak spot in our sector. There's not a ton of funding for it, so the more you can shorten those pathways and keep budget in mind to reduce costs, people get really they're really happy about that.
Brendan, actually, before you jump off the Felt thing, not to step on your toes, but wanted to add just a really,
You gotta go to the mic.
yeah, just a really quick thing on that, which is that in this case with Felt and sort of how we're looking at how these technologies all interconnect and work, this like interconnectedness piece is such a critical factor for how things are built in terms of API connectivity, because again, we are a very small development shop, right? And often I'm sure you all have experienced the same issue where it's like you're building an app or a service, and the more people you bring to the build party, like the more that thing turns into a Christmas tree. And what we see time and time again with folks is they're like asking us to rebuild analytics and things in our systems that this stuff already does right out of the box. So it's like, why are we gonna try and create a map editor that competes with Felt when it's already built? Like instead, the path is, let's make sure our APIs and our systems can easily connect to these services. And what I'm really excited about, like with, the AI hype cycle is one thing, but with all these interconnected services, folks can use this technology opportunistically. So in other words, if you have, a system like Felt where it has this crazy upload anything API where you can take like a Skyfi image that you've tasked and bought and just drag it into the browser and annotate it, like that's tech that can then very easily be integrated with your data set in FieldDoc or Airtable or whatever system you're using. So just want to emphasize that opportunistic tech approach, because it's really important for at least the folks that we support, and I think can also transition to other communities. So sorry.
Yeah, thanks, John. It's a good reminder, good point. And then Esri, we've all heard of Esri. They've made some strides in recent years to be more developer friendly. They've improved their documentation. I'll mention more about that in a few minutes, but that's been good to see, just because so many of our stakeholders have bought into Esri products and have accounts there. So what we don't want to do is go to them and ask them to completely abandon something they're familiar with using. And then there are some other players in a more general sense for, data management that isn't specifically geospatial. Airtable is one. They're pretty popular with a variety of different organization profiles, and that can range from small watershed organizations who have some longitudinal quality data up to foundations who are managing grant slates and that sort of thing and need to connect that to implementation data. And it's a very familiar interface for anyone who's used a spreadsheet before, so it's easy to get people up and running without a lot of friction. So the approach we've taken through FieldDoc is to say, rather than try to recreate all of these wheels with a 5-person team, we will do our best to provide the plumbing between our service and theirs so that we kind of meet users where they are and make it possible to sort of expand the collective benefit of using a bunch of systems and tools simultaneously rather than having the one true system that has to serve every need. There's a few things we look for, though, before we jump into an integration. If there's no documentation or it's opaque, then it's a no-go. It means that we don't know where things are going to be, post-implementation, and we can't trust it enough to pass on, to pass that on to our users with any confidence. There's a lot of systems now that have APIs, which is great, but it's even better if you can connect to them directly through user accounts. So we offer features for users to connect their FieldDoc accounts to these third-party systems. That gives you generally more access to the actions you can take in another system. And it's a common pattern. So we want to be using common patterns and not surprise our users. And there's the icing on the cake is if they have open source offerings, or if they are just generally being transparent about their value proposition, because for us, we can understand it immediately, but making the pitch to someone who we're trying to help, sometimes they don't see that as very helpful if they feel like we're just foisting more work onto them. So these third parties that have extensive tutorials and help documentation, it's really useful because then people don't have to take our word for it. They can go to the source. And so this all comes together in this concept called workflows. And workflows in FieldDoc are sort of the modular building blocks of different actions that you can take in our system and others. So whenever we have an integration, that might mean that we're running a model or something like that behind the scenes for users. Or it could mean that we're giving them direct control over things that happen. So they might have already adopted some other system that they're using to track their restoration data. And rather than making a mental shift to not only a mental shift, but also sometimes people see a new system and they think, oh, there's a new schema, there's a data model, it's going to take us years to migrate. And that's a significant barrier that we need to overcome. It's not really technical, it's a mental block. So when you give people the keys, they feel like they can see the data moving through the pipe, and psychologically, that's great for them. So we are still gathering user feedback and trying to identify the things that people would most like to see have connectivity to FieldDoc. And the nice thing is that whereas some of these projects would end up being one-off implementations that sort of rust in the field after deployment, we bring on integrations in a plug and play Lego block fashion so that it's easy to back out if you don't want to do that if you're a user, but it's also easy to offer feedback to our team and propose an implementation because that doesn't mean we're going to be herring off on a multi-year custom development cycle. You know, in terms of implementation details, I won't go too far into the weeds, but it's when there's an API, and most often it's a JSON API, then that means that we can map field doc actions directly onto API actions in another system. So if you're getting data out of a ArcGIS Online feature service, there's a standard set of facilities for that in the ArcGIS Online API. So once you've connected to it, you can expose that to users in a way that actually makes sense to them and just explain it using normal language. And this is part of our overall effort to democratize access to these systems. So people who don't have programming skills don't need to suddenly acquire them. They can let workflows do the heavy lifting. And that means that you tend to see more internal collaboration in organizations, which is nice because the data team isn't siloed away from the implementation team, and people that need to wear multiple hats are served as well, and they, perceive that we're being responsive to their feedback and trying to meet them where they are, rather than, again, continuing to impose top-down mandated solutions. Another big area where we collaborate to, integrate with other systems is when it comes to models, mathematical models. It's actually how FieldDoc got started. There's a big one in the Chesapeake that's developed by the EPA's Chesapeake Bay program, and it's called CAST. It's basically a scenario tool for practitioners who have some sort of, nutrient or sediment load target that they're trying to meet, and there's a web interface, and once upon a time where there was going to be an API, but that time has yet to arrive. So what we've done is we partnered with some representatives from the Bay program and also scientists from Virginia Tech University, who basically guided us along a process of saying, well, we have a lot of users who are seeking grant funding from National Fish and Wildlife Foundation and others in that region, but funneling all of them through that web interface that the EPA offers wasn't working. A lot of folks didn't really understand it. They didn't know why they were doing it. It was an add-on requirement to applications that they had to submit for funding. So embedding that into FieldDoc meant that suddenly someone with zero technical awareness of the model could input restoration practice data, and then FieldDoc would just run the models for them automatically. So it was a huge offload of the burden, and it's been great for the ground level folks, and it's been good for the funders and also the federal partners, because at the end of the pipe, they get the data in the shape that they need out of FieldDoc, rather than there needing to be a multi-step process and email chains with spreadsheets in between. So we've since expanded that initiative to include some collaborations with Drexel University and the state of Maryland's Department of Natural Resources, where we brought in models from expert panel reports and scientific papers and made them accessible through code. So the overall goal is to kind of unify what's a scattered ecosystem of one-off calculators and PDF files with examples of how to do calculations and stuff. People just aren't wading through those things unless they're specialists. And even then, life could always be easier if you could review legible documentation and sandbox in a model environment. So when we see something like this, which is fairly often, that's great, because it means people have at least consolidated their thinking into a paper or something that we can review in consultation with our partners. But it usually contains stuff like this, where there's some justification for a stream restoration practice, and then like a floodplain reconnection, and some math for in input variables and stuff, which is great. But again, people aren't going to do this. Grant applicants definitely aren't going to do this, and people who could access a model like this and generate value from it, they're also not digging through PDFs either. So next step is to say, great, is there an existing interface that we can look at to get a sense of how folks are addressing these models currently, and if so, can it be ported into FieldDoc somehow? And again, we're not doing this we're not just going out and pulling things in without talking to the modelers themselves first. So we generate the buy-in first, and then the implementation second. And it usually comes about after enough stakeholders have said that adding a given model would provide significant value. And sometimes we see stuff like this, and we get really excited because it means that we can just pass data back and forth directly to an existing API, and we don't need to go through the interim steps of reading reports and white papers and sitting in meetings with folks who are trying to suss out the details of some sort of BMP specification. So this is, I would say, not the industry standard, at least in our sector. So we often spend months and years working with partners to get to this point before we even agree to take on an implementation, because that groundwork is really important. But there's a lot of great research being done, and a lot of models that are developed in academic settings that would be highly beneficial to people, implementers on the ground. So there is a real need and a lot of potential in jailbreaking some of these models from their current homes and making them accessible through what we try to do is end up with a standard interface that users can build familiarity with without having to have a lot of background knowledge on any specific model. So the end user is just inputting a few additional parameters in line with the rest of their restoration practice data, so it doesn't feel like an extra thing that they need to do, which is really important because the old approach to this was to literally go to a different site or application and usually run through some scenario that might take a while and then generate a PDF and then upload that to a website somewhere. So that's not really what we should be doing anymore in 2024. There should be a single point of entry for all these things. And I'll go through these quickly. Another thing we're doing is to support users is this idea of linked pages. So that's just, you've got third-party analytics stored somewhere outside of FieldDoc, and rather than, again, spending development cycles and time and too much money making custom solutions, we can just pull in existing applications or visualizations into FieldDoc so that users can provide context for their practice implementation in a way that makes sense and matters to them, rather than imposing any specific presentation requirement on FieldDoc users. So it's really just building that flexibility, and also building educational opportunities, because anytime someone comes to us with an existing set of analytics or something that they put a lot of time into, they don't want to hear that they need to throw it out the window. So this is still sort of a new area for us, and we're still gathering feedback from folks on what's most relevant to them. So we're excited about that area. And then finally, this technical literacy. Mentioned before, we're just trying to start first with not writing any code and educating people first, because we see a lot of value in taking as much time as necessary to understand the context that people are working in, and making sure that they feel that we're being stewards of their mission as well, rather than just selling them product, which is not really what we're doing because we're a nonprofit organization. And then finally, we like to see, that ownership and adoption really matter to people. The most successful long-term projects we've seen are the ones where data practitioners at these organizations have worked with us to establish management practices and setups that really work for their needs, and that makes that that builds confidence. It means that it's an ongoing relationship for us, not just a simple transactional arrangement that is short-lived. We see this a lot across different systems, especially government systems. I hate to pick on government, but the timelines are often so long that users don't see progress. They don't feel like their data contributions matter very much outside of just some sort of, again, like a regulatory requirement or a stipulation in a contract or something like that that they need to meet. And so they do it and they go away, and that's it. It's very hard to rebuild trust in those situations. And we've seen that a lot in the Chesapeake region, where after over a quarter century of trying to clean up the bay, there's a lot of exhaustion and still a lot of issues around data that persist to this day because the groundwork was never done to convince people that data sharing would lead to better outcomes, and then that wasn't coupled with a commitment to offer people better tools. There's been a lot of stagnation. So core challenges, again, just siloing of tools. We like to build that glue code, that plumbing, those connection points to overcome those kinds of barriers. We want to shift the focus away from mandated reporting requirements to end user priorities, because that ultimately serves the collective a lot better in the long term. There's a lot of tools that exist today that allow you to gather explicit geospatial data describing where work is occurring, and it's important to get those tools into the hands of the people that could put them to best use. And then this last point is really key as well. When there's no chain of custody, there's no verification, there's no audit trail, and it's really hard for people who are spending the money on practice implementation to know where it was spent and who by and who to come back to later when there's a problem or there needs to be an expansion of effort or something like that. And we try to build in a way where there's a chain of metadata that's available at all times, and it's long-lived, it doesn't go away, it's stable. So if you are reporting to a state agency or something and their identifiers change or whatever, you still have your core piece of field doc data that can follow around wherever you need to send it. So, and at the state level, it's a real grab bag. It's a real mix in terms of workflows and expectations, and I think we see that as it's a long-term effort to try to not impose a standard, but offer a potential solution that is arrived at just by dint of people using the same system in a collaborative way. So I think that's where we're going to leave it for now and segue into questions and answers. Hopefully y'all have been letting the wheels spin as I've been talking at you. So I'm going to hand it off to John.
Awesome. Thanks, Brendan. Yeah, so just really quickly to kind of kick off the Q&A piece, I want to start with just kind of a prompt quickly, which is the last Slido on our poll here. And so, so with this, with this Q&A, we kind of want to guide this with just a starting point, starting prompt, but feel free, again, like any kind of question or discussion points on what we've covered, we're happy to kind of dive into that. But just to prompt you all, like, what data integration and or connectivity challenges have you all encountered in your work? And what's been your approach to address them? I think, again, we sort of, in planning this presentation, we were thinking a lot about like, well, so we've done a lot of this experiential work through our field doc system, but we know there are a lot of different ways to be tackling this. And that's, again, in terms of Brendan kind of demonstrating the integration pathways with systems like Pipedream or Python libraries or any of these systems. There's a lot of opportunity to kind of address some of those challenges. So I'm curious what you have. Feel free to type it. And then also can open it up to Q&A as well. So any questions just in general in terms of what we covered? Yeah.
So I was just curious, with Pipedream,
Yep.
looks like you guys are using a lot of OAuth stuff,
Mhm.
APIs,
Yeah.
are you running in, when you're using that software, are there limitations like costs that are associated with using those APIs?
Yeah, I'll let Brendan grab that one actually.
Yeah, it's a good question. There's usually some sort of discount offered to NGOs, but each call you make to those APIs or each run that you do in a workflow or something like that, there is a cost associated with that, but it's the folks that we work with aren't really operating at a scale where it ends up mattering very much. So and when it does, it's pretty easy to cost share.
I can also add too, one of the things that is sort of a challenging component with that too is sort of the different pricing structures of obviously each service, right? So even though it's like, man, stitching together these services, we can do just about anything. You obviously have cost increase, and then also your footprint turns into this like 800-headed hydra of like, what am I doing right now? I do think like the lens that we take, at least on a smaller scale, again, like we're not probably working at the scale that some of you folks in the room are, like whether you're at like a federal level, but like with our smaller scale groups that we support, we always trying to think about this as like a cost benefit in terms of like, could you set up or contract with somebody to set up an integration service that's very similar to Pipedream? Yeah, like there are libraries that could potentially support that and you could host that infrastructure. But the time to like set that up and maintain it, maybe in that case, it's a better cost benefit to like, buy a service offering on that front. So again, like it's really tough because we sort of try and weigh those costs and benefits with the different approach that we take. But yeah, that was a great question. Okay, so I'm gonna go to the chat. So this is a really great point. So building strong problem statements and business cases to highlight the purpose and value of integrations, depending on the stakeholder, and it's important to adjust the message. I think this is a fantastic point. A lot of these components can be like very in the weeds and discrete, support discrete workflows. So a lot of times people will be thinking about integrations, from the standpoint of what their own organizational requirements are, but then it becomes very difficult to articulate that out to sort of a broader set of, colleagues or people that have other ideas of things that have to happen. So I think this is a really good statement there. So any other questions? Yeah.
So I can see that you have authentication, so you
Mhm.
know who people are when they are using all these tools and the data. But do you have any issues with, how do you manage permissions? Like who's allowed to see and use which data sets? Or is that just not an issue here?
You mean in the connected system or in our own? Either one, yeah. So in our own system, we enforce access based on organization. So if you're a member of an organization, your data access is limited to the data that belongs to that organization. You can share data with folks outside your organization, just the way you'd share a Google Doc or something like that if you need to collaborate. And then the third-party systems enforce their own access rules that are just followed automatically when we integrate with them. So it's hard. It wouldn't be possible for you to break out and affect someone else's, Esri data or something like that from their connected account. So it's definitely a concern for most of our stakeholders who are managing sensitive practice footprints. We hear from ag folks all the time that they don't want anyone else to see their farm fields and where they're implementing BMPs. So from the very early days, we've been focused on privacy for the geospatial data.
Actually, got another quick thing to add too, just in terms of, I think it'll get at your question as well, and kind of also highlight some of the integration pieces that I think are really important. So as many of you know, like integration, right? It's a pretty loaded word because it can mean anything from like help me sign into an account and like let me set these specific rules in terms of what I'm doing with the data and the integration. And I think that one thing that kind of Brendan mentioned upstream with sort of how we've mentally been tackling integrations is sort of taking whole stock in like any system that we're looking at to integrate with and trying to understand all of the key elements that their API supports and breaking those down into bite-sized actions, right? So, initially when we would hear from stakeholders, they'd say, I want an integration with ArcGIS Online so I can sync all my field doc data with ArcGIS Online and make these really rad story maps and visualizations and use that. We're like, okay. But when we sort of got under the hood with that, we found, well, ArcGIS Online's API supports like all of these different utilities that could go beyond just sending data one way. In other words, like I could connect to an Esri feature service and bring that stuff in, and that's all supported in the API. So the approach that we tend to take with these integrations is breaking the API components down into functionality that can be reused. And so with workflows, again, users can kind of cobble together these different steps and rules with construction of a data pipeline. And I think that's, again, in your own work as you guys, if you are approaching sort of an integration problem, that's kind of an area it took us a really long time to kind of get our heads wrapped around it. But I think it's served us really well in terms of remaining flexible for end users. And then the last piece too, just because we are in the AI hype cycle here, right? This approach also positions us really well for down the road integration of API of AI in these integration services, because if you're breaking sort of these little workflow action steps into little pieces, that's a component that you could say like train an LLM on, like your code is well structured and kind of formatted to support that work. So yeah. So any other questions on discussions? And again, if you guys have any areas that, you have questions on, happy to address those. Yeah.
So if BMP implementation is sensitive information, is
Yeah.
that because it's like a proprietary business practice or because they're worried about
Yeah.
compliance?
Yeah, it's a great, so no, this is a great question. So typically it extends to agricultural best management practices. So in the Farm Bill, I believe it was the 2006 Farm Bill, USDA issued the Section 1619, which basically precludes sharing of farmer-specific practice information to other agencies for compliance purposes. And really the goal of that legislation was really to support and ensure that farmers don't get into kind of like a gotcha situation where they've essentially implemented a practice or said that they've implemented a practice and that practice is not there on the landscape. Because a lot of this stuff is really ephemeral. Like I think, and being a landowner myself, like, and a farmer, I can say that like, we've had, challenges with like forest buffer succession, right? And it's very unique, like the agricultural practice implementation, because, these farms are like homes to people that are living there. They're often doing this implementation work like at cost. And so it's something where, they're trying to be very careful to kind of protect that identity information there. And again, in our approach with this, we've really focused on, kind of the privacy piece and ensuring that all of that data is, locked down at the user and organization scale, so that it's incredibly secure. But it is something that we have to be aware of. But yeah, that's the primary reason for that. So, any other questions? Awesome. All right. Well, thank you all so much for the time today. It was great to present to you. Yeah, thanks.